All right, let's talk about something that is literally everywhere and in everything: energy. We're about to go on a wild ride, starting with that simple click, click, click of a roller coaster, climbing a hill, and zooming all the way out to the giant power grids that light up our entire world. You ready? Let's get into it.
So here's our game plan for today. We're going to start with the two basic forms of energy, then see how it pulls off its amazing shape-shifting act. We'll uncover the one rule that it can never break, and then we'll see how all of this scales up to power our planet and the big choices we face because of it.
First up, Section 1, Energy's Two Faces. The best way to think about this is like the difference between what if something happens and what is happening right this second. To kick things off, let me ask you a question. You've got a waterfall, a battery, and a stretched out rubber band. What on earth do those three things have in common? Well, they're all packed with energy, sure, but it's a specific kind. It's kind of like the energy of waiting. And that energy of waiting has a name: potential energy. It's energy that's stored up, just waiting for its moment. It's the energy of pure possibility. It's all about the what if. What if that water goes over the edge? What if you let go of that rubber band? And this potential energy is everywhere, hiding in plain sight. You've got gravitational potential. Think of a kid sitting at the very top of a slide. There's elastic potential in a spring you've pushed down. Chemical potential is locked inside the food you eat and the fuel in your car. And then there's nuclear potential, an incredible amount of energy held in the tiny core of an atom. So, what happens when all that potential is finally unleashed? Well, that's when you meet its other half, kinetic energy. This is the energy of motion. It's not what if anymore, it's what is. It's potential energy put to work. So to really nail this down, potential energy is stored up, ready to go, like a rock sitting on the edge of a cliff. Kinetic energy, that's the rock actually falling. One is waiting, the other is doing. Simple as that. Now, here's where it gets really interesting. Energy doesn't just sit there as one or the other. It's constantly changing, which brings us to Section 2, the Great Transformation. Just look at the incredible chain reaction inside a nuclear power plant. You start with the nuclear potential energy in atoms. That gets converted into immense heat, thermal energy. That heat boils water into steam, which spins a giant turbine. That's mechanical energy. And that spinning turbine is what generates the electrical energy that powers our homes. It's this massive four-step costume change for energy. But get this, the same thing happens on a super tiny scale. When you strike a match, the mechanical energy of your hand creates thermal energy from friction. That little bit of heat is enough to ignite the stored chemical energy in the match head, which then bursts into light and more heat. From a gigantic power plant to a tiny matchstick, it's all just energy changing its form. This leads to a really big question. If energy is always changing, does any of it just disappear? Well, that takes us right into Section 3, and what I like to call the universe's unbreakable rule. This might be one of the most important rules in all of science. It's the law of conservation of energy. And it's beautifully simple. You can't make energy out of nothing, and you can't get rid of it. You can only change it from one type to another. The total amount you start with is always the total amount you end with. Okay, let's go back to our roller coaster to see this rule in action. Picture it. You're in the cart. You've just been pulled to the very, very top of that first huge hill. You're holding your breath. Right now, you're barely moving, so your kinetic energy is basically zero. Almost all of your energy is stored up as gravitational potential energy. And then, whoosh, you dive down. At the very bottom of that drop, you're practically at ground level, so your potential energy is gone. It's zero. But you're going faster than you will at any other point, so every last bit of that stored potential has been cashed in for maximum kinetic energy. The sum of these two energies, the potential and the kinetic, is called mechanical energy. And here's the magic trick. Even though the amount of potential and kinetic energy is constantly changing places throughout the ride, their total, the mechanical energy, stays exactly the same. To put a real number on it, the source gives us this example. A 40-kilogram cart at the top of a 300-meter hill has a whopping 120,000 joules of potential energy. That number is the key. That's the energy budget for the entire ride. From the top to the bottom and everywhere in between, the total energy is always 120,000 joules. It's just shifting back and forth between potential and kinetic.
So now that we have the basic physics down, let's zoom out, way out. How do these rules apply to, our actual lives? This is section 4, powering our world. When you look at where we get our energy on a global scale, it really boils down to two main teams. You've got the non-renewables, which means there's a limited supply. Once we use them, they're gone. And then you have the renewables, which are naturally restocked by the planet, so they won't run out.
Your non-renewables, think coal, oil, natural gas, are basically ancient compressed sunlight. They're full of chemical potential energy that took millions of years to form. The problem? Well, when we burn them, we release CO2 into the atmosphere, and just getting them out of the ground can be pretty tough on the environment. The other option is renewable energy. This means we're tapping directly into the planet's ongoing processes, the power of the sun, the motion of the wind, the flow of water. And the huge plus here is that they generally produce very few greenhouse gases, and their fuel source is, for all practical purposes, endless.
So you might be thinking, easy choice, right? Let's go renewable. But it's a bit more complicated than that. And that brings us to our final section, our energy choices. Because it turns out, everything is a trade-off. Let's just lay it all out. Non-renewables, they give us a ton of energy and they're incredibly reliable. You can burn coal day or night, but they're running out and they cause pollution. On the flip side, renewables are clean and sustainable, but they can be dependent on the weather. The sun doesn't shine at night, the wind doesn't always blow. Plus, they can have really high setup costs, and we're still working on how to best store the energy they make. And here's the single most important idea to tie all of this together. Every single power station on this planet, doesn't matter if it's burning natural gas or using a giant wind turbine, is basically just doing the same thing as our roller coaster. It's an energy converter. It takes some form of stored potential energy and transforms it into the electrical energy that makes our modern lives possible. So we're left with this one final thought. We know from the laws of physics that energy is always transforming. The real question we have to ask ourselves now is how are we going to transform our choices about where that energy comes from?